Okay, so we're recording now. Okay, so topic 8, and today we're looking at ratios and scale. So this follows on from last week where we started talking about fractions, decimals and percentages, and ratios and scale are similarly about reasoning with proportions. And you would have seen on Milo that we write ratios in a particular way. So when we say down the bottom of this slide where we say cement, the ratio of cement to lime to sand is 1 to 1 to 6. That means that if we're making up this mortar for bricklaying, that we need 1 part of cement, 1 part of lime and 6 parts of sand. And the part size, it doesn't really matter what it is so long as we're consistent. So long as we have the same size of part, then so long as we've got 1 part of cement, 1 part of lime and 6 parts of sand, we'll get the same mortar mix. So we could have cup measures, so 1 cup of cement, 1 cup of lime, 6 cups of sand, or we could have wheelbarrows worth, 1 wheelbarrow of cement, 1 wheelbarrow of lime, 6 wheelbarrows of sand. So long as we keep our part size the same, we'll end up with those quantities in the same proportions. So ratios gives us another way, alongside fractions, decimals, and percentages, of talking about proportions. I'm trying to work out what okay. All right, so here's one for you to get your teeth into. Some of you have children who have just started homeschooling this week, which is a juggle, I know, for many people. Baby Panadol, children's Panadol, the dosage is calculated according to the weight, and we're fairly fortunate in that the Panadol box lists a whole bunch of weights that your child might be and the corresponding dosage, but obviously you can work out the dosage if you know how heavy your child is and you know how to think proportionally. So if we know that it's 1 ml for every 2 kilograms of body weight, then I hope you can work out for yourself, and I'll just write the answers here on the screen, but a 4 kilogram child is going to need 2 mils of Panadol, a 10 kilogram child is going to need 5 mils of Panadol, and a 7 kilogram child will be 3.5 mils. Okay, so that's an example of reasoning proportionally. You're thinking about keeping the proportion, this proportion, the same. So for every 2 kilograms of body weight, you need to give the child 1 mil. So you're really thinking how many lots of 2 kilograms are there in a 10 kilogram child? That's how many mils of Panadol I need. Okay, so another example of proportional reasoning, again, thinking about the quantities, how they relate to each other. So if it takes 20 minutes to travel 15 kilometres, how long is it going to take to travel 60 kilometres? So all of these proportional reasoning questions, and as we work through the slides, I think you'll find this, there are multiple different ways of approaching them. So some people like to think about things in terms of fractions, some people like to think about things in terms of percentages, some people like to work with ratios, some people prefer to draw little pictures. It's really up to you to think about what makes sense to you in terms of how to get to an answer for these kinds of questions. So for the first question, I like to, this kind of thing, I would often just draw a little diagram of some kind to represent the quantities. So 20 minutes to travel 15 kilometres. Now, suppose I want to travel 60 kilometres. What's that going to look like on my picture? Well, how many of those little intervals will I need? Well, another 3 of them, right? So if I go 15 kilometres 4 times, then I'll be I'll have travelled 60 kilometres, and each 15 kilometres is going to take me 20 minutes. So I can work out that it's going to take in total 80 minutes, or an hour 20. Second question, if it takes 4 people 28 hours to complete a task, how long would it take just one person? And if you haven't got your brain switched on, then some people will look at that and go, okay, 4 people take 28 hours. That means one person is going to take 7 hours. Oh, I can't write on that bit of the screen. It puts people there. Okay, one person 7 hours, but of course that's not right. And I'm sure you can see that that's not going to be right. So how long will it take one person to, so that was where I wasn't really reasoning proportionally. I was just going, oh, there are two numbers, I'll just divide them and see what I get. So if it takes 4 people 28 hours to do something, that doesn't mean that each person takes 7 hours to do it. If you just have, it means that each person is working for the, the equivalent of 7 hours. But if you only have one person working on the job, it's going to take them 4 lots of 28 hours to do it. So one person is going to take 28 hours times 4. So what is that? 112 hours. Okay. All right. So that's just a little example of reasoning proportionally. And you can do so. And the other thing, I guess, to note is that you can do these kinds of questions without bringing in any fancy apparatus of ratios or fractions or anything. You can just do them by thinking about them. And that's true for a lot of proportional reasoning. Sometimes it's handy to have a tool, but often you can think your way to an answer if you just kind of work through it methodically. So that's what you should be thinking about when you're doing these the ratio questions. And you should also be thinking, well, are there other ways to do it? And also, why does this way work? And really trying to get an understanding of what you're doing and how it's working. Okay. All right, so there are a couple of kinds of things that you have to do with ratios. You have to be able to find a ratio between two things. So if you've got two quantities, what's the ratio? What proportion is one of the other? So that's one kind of thing to be able to do. And the other kind of thing that is useful to do is being able to divide a quantity into a given ratio. So we'll get onto that second thing in a moment. First thing, how would you find a ratio of two quantities? So if we're asking what's the ratio of 2 hours to 30 minutes, it's the same as saying what proportion of 2 hours is 30 minutes. And the main thing to note is that firstly, ratios, because they're essentially unitless, it means that the quantities that you have in your ratio need to all be in the same units at the beginning. So to find out the ratio of 2 hours to 30 minutes, we need to convert hours into minutes. And so 2 hours is 120 minutes, and the ratio of 120 to 30, would write it like this. And ratios simplify in exactly the same way as fractions. So just as for a fraction, if you divide top and bottom by the same number, you get an equivalent fraction. Same with ratios. If you divide both sides or all parts of the ratio by the same number, you get an equivalent ratio. So these ratios are equivalent. And just like with fractions, we tend to prefer to write ratios in their simplest form. So the ratio is 4 to 1 of 2 hours to 30 minutes. And the proportion is just, it's 1/4. So 1 part out of 4 is 30 minutes out of 2 hours. It's the same as 1 part out of 4. And you'd write that as a fraction, you'd write 1/4. Okay, so the other thing to do is to be able to divide a quantity into a given ratio. And you should have seen this on Milo. So here's a fudge recipe. Sometimes recipes are written in terms of parts rather than in grams. That allows people to scale them up or scale them down to whatever size they like. So if you want to make a massive amount of fudge, you could use kilograms, 4 kilograms of condensed milk, 2 kilograms of butter, and so on. Or if you just want to make a reasonable amount of fudge, you would have a much smaller part size. You might have, 100 grams or something of each part. So you've seen on Milo an example of dividing, of making 1 kilogram of fudge. And when you're asked to make a certain amount of fudge using this recipe, what you're really doing is dividing that amount, so in this case on this slide 200 grams, into that ratio, so into the ratio given by the recipe, so into the ratio 4 parts to 2 parts to 2 parts to 1.5 parts to 0.5. So have a go, use a pen, piece of paper, and see if you can work out how much of each of the ingredients you need in order to make 200 grams of fudge. I'm going to pause the recording and give you a chance to do that. And then when you've got an answer, we'll discuss.